All right, so what I would like you to do is go ahead, take a look at these organisms here on the screen, and I want you to take these 4 organisms and create a food chain on your paper. If you have the printout, then there's actually a space right there for you to create your food chain. So go ahead, take a couple minutes right now and write down your food chain. You don't have to draw the picture, you can just write the name of the organism on your paper. All right, here's what you should have gotten. Wheat, because all food chains are going to start with a producer or an autotroph, with the exception if you include the bacteria I told you guys about, but that's a really small example there. So all food chains are going to start with a producer or an autotroph. So in this case, the wheat, and then the mouse eats the wheat, and when the mouse eats the wheat, the energy gets transferred to the mouse, so that's why the arrow is pointing in that direction. When the mouse is eaten by the snake, the energy is going to go to the snake, and when the hawk eats a snake, energy goes to the hawk. So energy is going to flow in one direction through the food chain, passing from one organism to the next as they're eaten. Now, one thing you're going to need to learn how to do is label the food chain. And I don't just mean the trophic levels. So here in this food chain, there's 4 trophic levels. Okay, so if we take a look at the food chain here, okay, we have 1, that's trophic level 1, trophic level 2, trophic level 3, and trophic level number 4. Okay, so there's 4 trophic levels. Okay, but you also need to label it in a different way, talking about whether they're producers or consumers. So what we can do here is label them with our basic words. So not the big scientific words autotroph and heterotroph, but using consumers. So here we have the producer, which is at the first level. The primary consumer would come next. And you could probably take a guess at what's going to be for the snake. It would be the secondary consumer. And then finally we're going to end with the hawk here, and he's going to be our tertiary consumer. Okay, so that's how we're going to label our food chain when we're talking about if they're producers, consumers, and what part of the food chain that they're actually in. All right, food webs. Most organisms on our planet don't just eat one thing. Now, there are a few things that are what we call specialists. Well, they will only eat one type of food. For example, pandas like bamboo, and that's pretty much all they'll eat is bamboo. Even more strict than that is a koala. Koalas will only eat eucalyptus leaves and nothing else. But for the most part, all other living things on our planet are going to eat more than one thing. So we don't just have simple food chains out in the real world. We have what we call food webs. Okay, so if we take a look here at our food web here, it looks really complex, but all it is a whole bunch of food chains that overlap each other. So here, if we start right here, here is the leaves. These leaves are eaten by this mouse, which is then eaten by this fox. These leaves are eaten by this grasshopper as well. And this grasshopper is eaten by this mouse, which is then eaten by the fox. Additionally, these leaves are eaten by the grasshopper, which is also eaten by the frog, which is eaten by the owl, or it could be eaten by the snake. Okay? So our food webs just show us how food chains actually overlap each other. There's not just one simple thing where one thing eats one thing and one thing only. The food chains are actually going to overlap each other in many different ways. All right, go ahead, write down this title on left hand side. How much energy gets from one trophic level to the next? Alright, I want you to take a look over here. Okay, so if we look over here, this is going to give us a clue as to how much energy, percent-wise, actually gets passed from one level to the next. Now, it doesn't actually say the percent here, but you go from 10,000 to 1,000 to 100 to 10. Now, if you're really good at math, you should be able to know that that is saying that only 10% of energy in one trophic level is actually going to get to the next trophic level. So only 10% of energy gets from one trophic level to the next. And you're probably wondering right now, okay, where did the other 90% of the energy go? If only 10% is getting from one level to the next, where's the other 90% of the energy? So on this slide here, we're going to answer that question. So where does all the energy go? Go ahead, write that down. Alright, so two things. First, if you think about what an organism does, what we talked about earlier, organisms are going to use the energy. That's why they eat. They use the energy in the food that they eat to move, to grow, to reproduce. So they actually use up the energy. So that's one place that the other 90% is going to go. The second thing, a large majority is going to be lost as heat. Okay? So our bodies are constantly creating heat, and that heat is energy. So energy is a form of heat. So that energy gets lost from our body that way as well. If you've ever gone for a run or you've exercised really, really hard, and when you stop, you just feel that heat coming off your body. It just feels like a blanket of heat all around you. That's because your body has created a lot of energy in the form of heat, and that heat is lost off of your body. So that's going to be the two ways that energy is going to be used up or lost, and then that leaves only 10% that can be available and passed on to the next trophic level. Alright, now what I'm going to give you, or what I'm going to do right now is I'm going to give you guys some time to go ahead and write your summary on your notes, and then after that the sub will go ahead and start the next video for energy and calculating energy.